We are Silicon Valley, a student team led by Professor Min-young Tae of the Department of Nano-Semiconductor Engineering. First of all, we are going to introduce you our theme, the silicone-based electrospun nanofibrous patches for low-frequency stimulators. And we'll announce our future research plans. Our table of content proceeds in the following order. First, we are going to explain the reason why we chose this topic and the current situation and the problems of the existing product. Second, we are going to give you our suggestions about how we are going to change things and how we are going to make the samples and prototypes. Also, we will explain how we are going to check or measure the results if the thing is going alright or not. And at the end, we are going to tell you our goals in this project and how we distributed roles to each members of the team. So these are what we prepared. Low frequency therapy devices can be classified into two types. One is for its usage and the other is how it works. Left on the slide shows test method mostly used by medical institutions. Injecting under 250 Hz pulse current directly to the muscles, they help with relaxation and contractions of our muscles. Right on the slide shows EMS method. It's kind of like portable massage machine. It stimulates the muscles under your fat using very small amount of current.
Existing products we mentioned in the previous slides have four major problems. First, it doesn't stick to our skin very well, so we need to put some sticky gel on it or nip band to fix it. Second, when we use the gel, the product can be easily contaminated by dust or something, so it's unhygienic. Third, existing products are mostly made of plastics or silicone, which is hard to stick on curved body parts like knees or elbows. So the current will be concentrated, which can damage our skin. The last thing is that existing products are not made of eco-friendly materials and is not recyclable. We thought there were needs of improvements for customers' demands in rapidly developing medical device markets. So we planned to make developed one. We are going to make nano silicone-based fibrous patch. It sticks to our skin very well, so that gel won't be needed anymore. Its porous structure will solve the problems with sticking or hygiene issues by sweats. Also, it is bendable and stretchable, so that patients can move freely and the therapy will be more comfortable. Our product is made of eco-friendly silicone material and it can be easily separated from the main body, which is good for recycle.
Now I'll explain the prototype production process in detail. The main process in our study is electrospinning. Electrospinning applies an electric field to liquid polymers to create a fine product with a diameter of hundreds of nanometers. This is a method of producing continuous fibers. As shown in enlarged image on the right, when a voltage of a certain level is applied to hemispherical polymer, it turned into a cone shape, which is called Taylor cone phenomenon. When we use this phenomenon, we need to create a spinning solution by mixing the main material with the corresponding solvent. Then we put the prepared solution in syringe, attach into the pump and set the spinning speed. And lastly, we set the strength of the voltage to be applied and applied the voltage, then it makes a polymer jet and it's collected in our collector. And this photo is showing actual appearance of electrospinning. The left shows a schematic diagram of our sample. Looks like a sandwich, and we could divide part as front part and rear part, and low frequency transmission line, and lastly connection terminal. And this machine is electrospinning machine that we used as our process. And this parameter is the chart we use to make our fibers. To prove that silicon fiber can transmit low frequencies, we created a prototype by electrospinning it directly as a low frequency transmitter. This picture shows an example of silicon nanofibers, and this picture shows an example of a low frequency transmitter coated with electrospun silicons. And this picture shows example of connection terminal.
We choose SEM measurements to check the silicon fibers or in the form of porous nanofibers. SEM, scanning electron microscope, is a device that shoots an electron beam onto a sample and detects electrons reflected from the surface. Image on the right side shows the example of nanofibrous structure taken by SEM. This slide shows the ways of measuring our samples. It is very hard to check if it works properly by only seeing the SEM image. So, we have planned to use the comparative method.
We expect that our one-time use nano silicone-based fibrous patch will solve the problems that existing products have. First, plus for the hygienic and sticking better. Second, bendable for the all parts of the body. Third, attaching well. Lastly, eco-friendly for the environment. Our group will proceed as follows. This presentation was produced with reference to these sources. Thank you.